Luminaires should have adequate mechanical strength and be manufactured in such a way that they can resist rough handling. Blows are applied to the luminaire using the hammer test. Requirements in the standard are rather low, so stricter criteria are used in the Schréder Artec laboratory. In order for a luminaire to pass the IK8, it must resist an impact of a 1.7 kg weight dropped from a height of 29.4 centimeters. A special support is used to position the luminaire in such a way that the hammer always hits it in a direction perpendicular to the surface tested. The most sensitive part of the luminaire is its protector. Different parts of the luminaire are exposed to the hammer blows. For the envelope, slight distortion can be accepted provided that the tightness remains intact. Schréder's goal is to produce optics without any internal maintenance. Therefore, Schréder luminaires are tested to solids almost exclusively for tightness degree 6. The tests are performed in the Schréder Artec laboratory in accordance with EN 15986 using a particular talcum powder. The luminaire is placed inside the dust chamber and switched on to its normal working conditions. The fan is activated, provoking an intense powder cloud. After 1 minute, the luminaire is switched off, but it remains inside the dust chamber for 3 hours with the talcum constantly moving everywhere around it. After this 3-hour test, the luminaire is removed from the chamber, cleaned thoroughly from the outside and then checked for some dust particles inside it. For tightness degree 6, no traces of dust at all should be found inside the luminaire. If some traces of dust can be found inside the luminaire, it only passes degree 5, provided that this dust is not electrically conductive. The Schréder Artec laboratory is certified by Senelec and allowed to issue tightness degree certificates for Schréder luminaires. In the Schréder Artec laboratory, different tests defining the tightness degree of a luminaire can be performed. The available equipment allows the IP tests to liquid for degree 3, 4, 5, 6, 7 and 8. Before starting the IP test to liquid, the lamp is switched on during a preconditioning period up to temperature stabilization inside the luminaire. For degree 3 to 6, the luminaire is fixed on a support turning 1 turn per minute. An arc with small nozzles sprinkles water on the fitting and moves 60 degrees down on each side for IP3 test and 180 degrees on each side for IP4 test. These tests last for 20 minutes. For IP5 and 6, a high-pressure water jet is used from a 3-meter distance. Parts of the luminaire sensitive to water penetration are more heavily sprinkled. Just before starting the test, the luminaire is switched off and the air pressure inside the luminaire decreases, creating a tendency to suck in the water. For tightness degree 5, the test lasts for 15 minutes with a jet pressure of 300 grams per square centimeter. For tightness degree 6, the water pressure is increased to 1 kg per square centimeter and the test lasts for 3 minutes only. The very high pressure makes this test extremely severe. For IP7, the luminaire is placed inside a pool 1 meter below the water surface for 30 minutes. No water may enter inside. This test is used for luminaires that may accidentally get underwater. Luminaires dedicated to submersion are tested to IP8. The luminaire is submerged at a deep 30% superior to its normal utilization in order to make sure it resists the hydrostatic pressure.